Okay, hello, pre-calc. It's just me again. That's totally all right. Let's jump into again. We're kind of been working on these derivative ideas. So let's take a look at what we've got. So again, really kind of intro, kind of started working on derivatives last week. This week, really looking at the power rule, the product rule, and the quotient rule, and how to find those and work with those with derivatives. Now, we'll run through some examples of those, and we'll do the chain rule next rule. So the power rule is kind of basic. The power rule works where it's really whatever our exponent is, we take the exponent down to the front. So if we had x to the third, we would move that 3 to the front, and then we subtract our exponent by 1. So it would be 3x squared. And so that's kind of the generic. So again, if I had 5x to the fourth plus 10x, it would be bring the 4 down in front of the 5. 4 times 5 is 20. 20x, 4 minus 1 is 3. 20x to the third power. And then the 10x would just be a derivative of 10. So that's in general, really, really fast, quick overview of the power rule. And that kind of leads us, or we have to be able to find these derivatives. We have to use the power rule sometimes to determine or help us with the product rule. So the product rule works like this. Again, if I have two things that I'm multiplying together, I'm going to start by taking I'm going to start by taking one of my pieces of my multiplication. I'm going to keep it the same. And then the other part, I'm going to multiply it with the derivative of the second part. And then I'm going to add, and then I'm going to find the derivative of that first part, and then I'm going to multiply it by the second part, the original second part. So if I look at this example, and so they say to find the derivative, we need to take the derivative of du, so the derivative of this, multiply it by v, and then I'm going to add the derivative of v and multiply it by u. So again, I take the first times the derivative of the second plus the second times the derivative of the first. That's kind of a way that I like to think about it. The product rule is the first times derivative of the second plus the second times derivative of the first. So if we look at this again, it's helpful to kind of figure out your derivatives first. So again, I'm going to say, okay, if I take the first function, which is 3x minus 5, I'm going to multiply it by the derivative of the second, which is going to give me 4 times 3x minus 5, plus the second function, 4x plus 7, multiplied by the derivative of the first, which is 3. So 3 times parentheses 4x plus 7. And then you just got to go through and simplify, combine like terms, and you eventually get that the derivative of this function, which was u of x times v of x, is 24x plus 1. So a very generic, a very sort of simple example of the product rule. The quotient rule is a little more complicated. It's got a little bit more. So we've got the numerator and the denominator, also kind of known as the top and the bottom. So we have the quotient rule, like the phrasing, the saying that I use to help remember me is low D high plus high D low, and over the square of low we go. Or excuse me, low D high minus high D low, and over the square of low D high of low we go. So low, so take the denominator multiplied by the derivative of the high, which is u. So again, low D high minus high, which is u, multiplied by the derivative of the low, which is v prime, and over the square of low we go. Okay? Low D high minus high D low, and over the square of low we go. So if we put that into practice, I'm going to have to determine what the derivative of the top is and what the derivative of the bottom is. And when I start to plug it in, I get low times the derivative of the high minus high times the derivative of the low, and over the square of low we go. So I start to simplify and I can combine like terms and I end up getting an answer of 41 over 4x plus 7 squared. It's fine in this example to leave it like this. Sometimes you may want to multiply this out. You may be able to simplify further. So again, depending on sort of the problem or what you're working on. Okay, again, those are the chain, or that's the product and the quotient rule. Really quick, sort of simple, easy examples. When we add our pre-calc twist to it, again, we can find derivatives of trig functions. So I believe it goes through and shows you and proves how each one is. Maybe we'll just look at sine. So again, if we're trying to find the derivative of sine, and we go through our limit definition of a derivative, and we go through all of these steps, I end up getting cosine. So it's good to know. Make sure you jot these down, because again, when you're using the product rule or the quotient rule, you're going to have to know what is the derivative of tangent, what is the derivative of cosine. So you can see the 6 main trig functions right here. Again, the derivative of cotangent is negative cosecant squared. Again, you can find it by hand, but it's more difficult, and it's better to have these written down that you can reference when you're doing the quotient rule. Low D high minus high D low, and over the square of low we go. So yeah, there are proofs that go along with this, and again, prove why each of these works. I'm more, again, focused on the practical uses. So again, make sure you've got these written down. Just gonna buzz through these to see if we can, again, if you want to pause and you want to try some of these, I'll just throw them up here. Pause it. Again, this is a great example of the product rule. First times derivative of the second plus the second times the derivative of the first. Low times derivative of the high, low times derivative of the high minus high times derivative of the low, and over the square of low we go. Product rule, first times derivative of the second plus second times derivative of the first. This is partly you would have to use the chain rule. And we haven't quite learned that one yet. Next week. What is the derivative of cosecant? Right here. What is the quotient rule? Low D high minus high D low, and over the square of low we go. And again, notice what's on top, what's the high, what's the low. So again, I'd have to be able to determine what is the derivative of x squared. It's 2x. What's the derivative of sine x? It is cosine x, excuse me. The derivative of sine x is cosine x. Once you know that, you can go ahead and solve it. So you could keep going, again, depending on how big that exponent is. You may have to do it a lot of times until you run out. First times derivative of the second plus second times derivative of the first. Product rule. Okay. Let's look at the Class Connect assignment. Again, we'll be finishing this unit up next week with derivatives. Your Class Connect assignment is find the derivative of each trig function. It's right there. Low times derivative of the high minus high times derivative of the low, and over the square of low we go. And again, make sure you know what the derivative of sine x is. All right, let me know if you have any questions. Keep working hard, get that work turned in.